Welcome to Chapter 5, where we will explore one of the most powerful forces shaping work throughout history, technological change. Today we'll examine how technology doesn't just change what we do at work, but fundamentally transforms entire occupational structures, skill requirements, and power relationships in the workplace. So, I want you to think about your own work experience, whether it's using computers, software, smartphones. These technologies do not just make tasks easier, they completely reshape how work gets organized and who has control over work. So, let's start with a crucial point. Technology is much broader than the electronic devices we often think of. The textbook defines technology as the use of knowledge and organization to produce objects and techniques for the attainment of specific goals. So there's three components: knowledge, organization, and specific goals. The knowledge doesn't have to be scientific. Many technologies throughout history were developed through trial and error. Medieval ironworkers made high-quality steel for centuries without understanding the metallurgical science we know today. But here's the critical question we need to keep asking. Whose goals are being pursued? This isn't really a neutral question. The technologies that get developed and implemented often reflect the interest and power of those who control resources and make decisions. One of the most important concepts in the chapter is rejecting technological determinism, the idea that technology automatically determines how society changes. Well, this view treats technology as if it has a life of its own. It's inevitably pushing society in certain directions. Instead, we need to understand the social shaping of technology. Technologies don't just appear naturally. People with resources and power decide which tech to invest in, develop, and implement. So this means technology often reflects and reinforces existing inequalities in wealth, status, and power. Think about workplace surveillance technology. Managers don't implement employee monitoring systems because the technology forces them to. They choose these technologies because they align with the goals of controlling workers. To understand why we are where we are today, we need to see the big picture of technological change. So, we've experienced three major technology driven revolutions that fundamentally altered work and society. So, the first one, the agricultural revolution, thousands of years ago, transforms humans from nomadic hunters and gatherers into settled farmers. So, this actually created the first major division of labor and permanent settlements. The Industrial Revolution gave us machines, factories, wage labor, completely restructuring how work was organized and when it took place. Now we're in what many are calling the Information Revolution or post-industrial society. Less than a century ago, most Americans worked in farming, mining, and manufacturing. Today, the service sector employs the majority of workers. This represents one of the most dramatic transformations in human history. The fear that new technology will destroy jobs is as old as technology itself. The Luddites weren't anti-progressive fanatics. They were skilled textile workers whose livelihoods were genuinely threatened by new machinery. They saw their economic security disappearing and fought back the only way they could. This pattern has repeated throughout history. In the 1930s, during the Great Depression, some government officials seriously considered a techno tax, charging companies extra for replacing workers with machines. In the 1950s, the term automation became associated with fears of permanent mass unemployment. These examples in your textbook show this isn't just historical. Ford Motor Company produced the same number of vehicles in 1988 as 1978, while employing half as many workers. The steel industry production by 20% was increased while cutting 17,000 jobs. Today, we're having similar conversations about AI and robotics. The question is, are these fears justified? So, the textbook explains why fears of permanent technological unemployment are usually wrong, and it comes down to what economists call the lump of labor fallacy. The fallacy assumes there's only a fixed amount of work to be done in an economy. If machines do some of that work, there must be less work for humans to do. This isn't exactly how economies function. First, new technologies create entirely new kinds of jobs. Entirely. There were no positions for X-ray techs before X-ray technology, no web designers before the internet, no app designers before smartphones. Secondly, when technology increases productivity and lowers costs, those savings get spent elsewhere in the economy. Whether it's lower prices for consumer, higher profit for owners, or better wages for other workers, that money creates demand and jobs elsewhere. Most importantly, there's no shortage of work that needs to be done. Environmental cleanup, infrastructure repair, healthcare for underserved populations, education improvements. The challenge isn't lack of work, but organizing society to pay for the work that needs to be done. One of the most complex aspects of technological change is its impact on skills. The textbook shows this isn't a simple story of upskilling or deskilling. It's both happening simultaneously in different parts of the economy. Some jobs clearly require higher levels of technical skill. Think about healthcare workers using diagnostic equipment or manufacturer workers operating computer control machinery. But other jobs have become more routine and require fewer skills, like data entry or simple assembly tasks. Research shows these trends largely cancel each other out across the economy as a whole, but this creates a particular challenge for individual workers, especially older ones. Here's an interesting finding that challenges stereotypes. A study of Pennsylvania state agencies found that older workers were actually more willing to learn new office tech than their younger counterparts. The real barrier isn't ability or motivation. It's that employers often don't provide retraining opportunities because they assume older workers can't or won't learn. This is where we get to one of the most important arguments in the chapter. Technology isn't just about efficiency, it's often about power and control. The textbook describes how mass production technologies were appealing to managers, not just because they were efficient, but because they reduced dependence on skilled workers. Skilled workers have leverage. Their expertise is difficult to replace. This gives them some power in workplace negotiations. By designing technologies that could be operated by unskilled workers, managers gain more control. As one Ford engineer put it, they had no use for experience. They wanted workers who have nothing to unlearn and will simply do what they are told over and over again. So this pattern continues today. Numerically controlled machine tools could have been programmed by recording the actions of skilled machinists, but managers preferred to have engineers, part of the management team, do the program instead. Modern electronic technologies extended this further. Keystroke monitoring, GPS tracking, productivity software that counts every action. One observer called computers the electronic equivalent of assembly line to mechanically pace and control workers. Here's the fascinating counter trend. the textbook identifies. While some technologies increase managerial control, others actually shift power to the workers. The key insight is that computers have made information incredibly cheap and widely available. Traditionally, one of the management's main source of power was controlling access to information, that being the handler, manipulator, dealer, and withholder of information. When workers have direct access to production data, customer info, and operational details through computer systems, they become less dependent on managers for information. This can be really threatening to traditional authority structures. The textbook quotes a manager saying, "It's kind of scary when you give workers at control stations tremendous technology power to see all the functions of the operation." This shift matters because today's economy increasingly depends on service work, where you need employees who can respond creatively and intelligently to customer needs. Even in highly automated manufacturing, things go wrong and humans need to intervene. Often workers at the bottom of the hierarchy who understand the actual production process better than their managers. One of the most visible ways technology has changed work is enabling telework or telecommuting. We might call it work from home. The textbook notes this represents a return to historical patterns before industrialization, where most people worked where they lived. The numbers show significant adoption. About a quarter of American workers do at least work some hours from home, although most do it only occasionally. It's particularly common among working parents, especially mothers, who use it to balance work and family responsibilities. The benefits are real. Reducing commuting saves time and money. Many people report being more productive without office distractions, and it can significantly reduce work-family conflicts. But the challenges are significant. Many workers find it harder to advance their careers because they miss out on informal networking and visibility that comes with being physically present. Face time still matters for promotions and new opportunities. There's also the issue of boundaries. When your home is your office, work and family demands constantly collide, creating a new form of stress. The textbook quotes one economist calculating that commuting costs Americans 25.4 billion person hours annually, time that could be worth 356 billion if spent on productive work instead. The final section of this chapter connects technological change to globalization, one of the most powerful forces affecting work today. Globalization isn't new. The textbook reminds us that European discovery of the New World was enabled by ocean-going vessels and improved navigation. What's different today is the speed and scale of global connections. Transportation technologies have shrunk the world dramatically. Where international trips once took weeks, we can now travel between continents in less than a day. But even more importantly, information now travels at the speed of light through digital networks. One of the most important but overlooked technologies is the simple shipping container. This metal box revolutionized global trade by enabling intermodal transportation. The same container can move seamlessly between ships, trains, and trucks without breaking bulk. In 2008, the world handled 152 million standard containers. These technologies enable global supply chains, international financial markets, and real-time collaboration across continents. For workers, this means both opportunities, access to global markets and knowledge, and challenges, competition from workers worldwide, and potential job displacement to lower wage regions. So let me summarize the key insights from this chapter. The most important takeaway is that technology is not a neutral, independent force. The technologies that get developed and implemented reflect human choices, and those choices are influenced by who has power and resources in society. While new technologies can displace specific jobs, this doesn't necessarily lead to permanent unemployment. But the transitions can be genuinely difficult for individual workers and communities. The creative destruction that Joseph Schumpeter described creates winners and losers. Skills matter enormously in navigating technological change, but we can't just tell workers to adapt. Access to quality retraining and education opportunities is crucial, and research shows that even older workers can successfully learn new technologies when given proper support. Perhaps most importantly, we need to recognize that the trajectory of technological development isn't inevitable. We have choices about which technologies to invest in, how to implement them, and how to distribute their benefits and cost. These discussion questions are designed to help you think critically about your own experiences with technology and work. They aren't abstract issues, they affect all of us directly. The personal reflection question helps you see that technological change has always had winners and losers. It's never neutral in its effects. You might think about how online learning affected you differently than your professors, or how smartphones changed work opportunities and expectations. The skills assessment pushes you to think proactively about your career development. In a world of constant technological change, adaptability and continuous learning become more important than any specific technical skill. The policy debate question gets at the heart of social responsibility. If companies profit from labor-saving technologies, do they have obligations to the workers they displace? This connects to broader questions about the social contract and the role of government in managing economic transitions. The current examples give concrete cases to analyze using the frameworks from the chapter. You can apply concepts like technological determinism, the lump of labor fallacy, and power dynamics to understand contemporary workplace changes.